So in a previous tutorial, I showed how to generate a stretchy joint structure by using two multiply-divide nodes and a distance measure. And the result was this. Okay. Now, of course, you need both the multiply-divide nodes so that you could, for one, set up the stretching, and then feed the output into the scale. Two, so that you could set up a sort of a generic scale so that if, let's say, the global rig was scaled down, it would actually pay attention to the scale, and therefore everything would still work even at smaller or larger scales. Now, the second version that I've come up with is not going to affect actually the scale of each joint. Instead, it's actually going to affect the translate value. So instead of having to scale the joints, it will merely translate them to create the stretching effect, which actually works rather well. And it uses some of the same techniques as the previous version. Okay, so unlike the previous version of the stretchy setup, in this case, you're going to have to actually pay very close attention to the translate values that have been defined for the joints that are going to be affected by the stretch. Now, also, something that varies is that instead of controlling the translates for the joints from, let's say, if you're going to work on the arm, for example, instead of doing it from the initial joint and not including the last joint, because the last joint, if I were actually to scale that one using the old setup, it would actually move the hand, which wasn't supposed to be part of the stretch. In this case, the translate value of the end joint will have to be included in the stretch, while the translate value of the shoulder should not be touched. So what we're going to need is we need to create some nodes. We're going to need to create a plus minus average node for each one of the joints being affected by the stretch. In this case, it's not going to be, the start joint will be unaffected, so we don't need a node for that one. We need a node for the elbows. So I have two, so I need one for each, and we need one for the wrists as well. So I'm going to my Hypershade, Utilities, go to Create tab and choose Utilities, and scroll down until you find the plus minus average, which is right here, plus minus average, and then just click on it once. And in general, we're only going to need to create one, and then we can duplicate it. So I'll create the one, double click on it, bring it up in my attribute editor, okay, and then in my attribute editor I can make a few adjustments. So the plus minus average node is can be a little tricky if you're not familiar with it. By default, you have pretty much what you see here, and the operations available on it include sum, subtraction, and averaging. In this case, we're going to use sum because we want it to continually add input. And just for simplicity's sake, I'm going to use input 3D. If you use input 2D, you can actually have 1 and 2 inputs, basically an X and a Y. If you use input 3D, you can have a X, Y, and a Z. I tend to use this one by default just in case I need to use the other options. I don't need to make additional nodes, as you can just use the one. So in this case, we do have 1, 2, 3 joints, but I'm going to create a node for each one just to keep it as clear as possible, because you never know. Okay, so I have my node, and I usually like to rename them. So I'm going to rename this one. I'm going to call it my P-min, and we'll call this one elbow 1. And then I'll duplicate it, and it'll immediately call it elbow 2. Duplicate it one more time. Control D, or Command D if you're on a Mac. And then I'm going to name my last duplicate for the wrist. So this is going to be my wrist. Okay? Now next, once you actually have all of your nodes created, we need to go in, double click on each one, And under input 3D, you want to click the add new item so that you can create input 3D 0 and input 3D 1. And so now for each one of your plus minus average nodes, once you actually have each node created, you want to select the joint that corresponds to that node and then find out what its translate x value is. Usually the translate x value is the one that you're going to need if your joints are oriented so that, or created so that the x-axis flows through the joint structure. It's changing the x-axis will actually change its position and therefore initiate the stretching. So in this case, my first elbow joint has a value of 0.885, and so I need to go to that first elbow node, and from my first input I'm going to put in 0.885. Don't worry about if it averages the value. It still recognizes that you input 0.885. And so for the next elbow, go in, find its translate x value, which is 0.113 in this case. Go to this second node that's going to correspond to it, and again you want to put in 0.113, and then find the wrist, and then same thing, find its value, 0.752. Double click on the node that's going to correspond to the wrist, and put in the value, which in this case again was 0.752. 0.752. Now the translate x values that you have here correspond to each joint's distance from the previous joint in the hierarchy. Okay? So there's no need to measure this. You pretty much just click on the joint and it tells you exactly how far it is from the other joint. And that's what you need to put in as the defaults. So once you have those defaults in place, we can move on to one more step. We're going to create a multiplyDivide node. So while we still have our Hypershade open, we go to the Create tab, go to Utilities, and then scroll down until you see multiplyDivide. Click on it once to create a node, and then again you can rename it. Now this one is going to control the stretchy, essentially. And so I'm going to call this one my mdiv, and we'll call it stretch. Okay. Now we have the 4 nodes that we need. Each one of my plus minus average nodes now has the default position of each joint inserted, and so now we need to feed the output of each one of these nodes into each joint that's being affected. And so what I can do is I can select my plus minus average nodes, and then I can go to Window, General Editors, Connection Editor. Reload my left side, which is usually the side you want for your outputs, and then go to the left display, tell it to show non-keyable, and then we can see all of the outputs for our nodes. Now our output is going to be from the output 3D attribute, and so you need to expand those so that you can actually see the output 3dx, which is basically the position that we put our values in the x position. And then what we can do is we can select each joint. So I'm going to select the elbow 1, reload my right side, make sure it's only showing the basic inputs, so show inputs only, it's not showing the non-keyable. And I need to expand the translate values, and then I need to find the plus minus node for the elbow 1, and just left click on its output 3dx value, and then left click on the translate value. Now if I've done this right, there shouldn't be any change. Now notice, even though the plus minus average node, it rounded the value that was being displayed, it still input the appropriate value into our translate value. It put in the value that we actually typed in. So now I'm going to repeat the process for each joint. So I'm going to reload the right side with my elbow joint, expand its translates, find the elbow 2, my second plus minus average node for elbow 2, output, translate. And then last but not least, the wrist. Reload that, expand the translate, find the wrist, find its output 3D, find its output 3DX, click on it, and then left click again on the translate X for the wrist. And so now that those connections have been made, and notice that the arm has not moved, okay? Because it's currently still in its default position. All the default values are still consistent. Next, we need to make control to control our stretching. So you can pretty much use anything. It doesn't really matter. You could use an empty group. You could use a box. It doesn't matter. Just something that you're going to use to control the stretching. In this case, I'm going to go to my NURBS primitives and create a circle. I'm going to scale it down a bit. And then I'm going to snap it to the wrist position. Now, ideally, when it comes to these things, I like to orient everything so it's consistent. So notice how the arm actually angles down a little bit. I'm not going to worry about that too much right now. I'm just going to show the setup. So I'm going to position the control here, and we'll relabel our control. I'll call this my extend, and then I'll freeze it because we're going to need its translates to be at 0 in its default position, which it's currently in. Okay? And so now its translate X is going to be used to influence the scale or the translation of our joints for our stretching. So I need to actually feed this into my multiply-divide node. Multiply-divide node is going to be used because we need it to basically diminish the influence of our curve on each one of the joints. We can't have it feed the total translate value into each joint, because then essentially it's going to be feeding it in 1, 2, and 3 times, so it's going to basically overshoot the position of our control. We want it to basically to stay relatively aligned to it. So what we're going to need to do is take our multiply-divide node, load it into our connection editor, and then take our control, load it up in the outputs, make sure that we're just seeing its top level inputs, so just showing the readable. We need to take its translate X, which corresponds to the direction that we're doing the stretch in and the orientation, and we need to feed that in to our plus minus divide node. Now the one thing about the plus minus divide node is you want to make sure that it's set up not to multiply as its operation, but to divide. And then what you want to do is you want to feed the translate X input into the input 1, which is basically the input being divided. Okay? So we need to connect translate X into the input X. And then one last thing we need to do is we're going to need to actually feed our multiply divide number value out to each one of our plus minus average nodes. But while we're and we'll take care of that right now. So I need to bring up my plus minus divide nodes, select all 3. I'm going to reload them into my right side just for consistency's sake. Reload my multiply divide node into the output side, and we're going to make sure that we can see its outputs by showing the non-keyable. Again, that's under left display, show non-keyable, so you can see its outputs. And we need to feed the output from this node into the input 3D of each one of our nodes. Now remember, we created an input 0 and an input 1 for each one of the nodes. Now the input 0 on each one should be receiving input from, or should be feeding out to our joints. So we don't want to overlap those. If you don't remember where you actually input the value for the translates, you want to make sure you check. Now, in this case, we put it under the input 3D0. So we're going to actually connect into the input 3D1 value of each one of the nodes. Okay, so we're going to feed our output into the input 1 under the input 3DX, input 3D1 under input 3DX, and input 3DX. So yes, it's actually outputting the same value to each one of our joints. Okay? And so if we actually double click and take a look at our node, we see that now that value has an incoming connection. Now, here comes the tricky part. We need to make sure that our multiply-divide node is equally dividing the input from our extend control by the number of joints being affected. And so in this case, we're going to have 1, 2, 3 joints being affected because we don't need the base of our arm to basically stretch or to translate. We just need the elbow joints and the wrist to translate. So in our multiply divide node, we're going to set it to a value of 3 because it only has 3 joints being affected. Okay, so once that's done, all we have to do is come in and start translating. And that's it. So as you can see, it's translating and stretching relative to the distance. Now, of course, our arm is on a downward angle, so it's sort of moving away from our control. But if we come in and, of course, add an IK in from shoulder to wrist, and then take our IK handle and just parent it to our control, or make sure it's basically moving in the same direction as our control. So even if I don't parent it and I just grab both of them and translate them together, you'll see that now the arm stretches and it stays aligned with our control. Okay? Simple enough. Now, the last part of our setup is not unlike the previous setup, is we need to come in and prevent all of our joints from basically shrinking. And so what we need to do is we need to come in here and we need to tell our joints that they can't go below a certain value. So selecting each joint individually, go to your attribute editor, go to the first tab and find the limit information. Expand it and find the translates. And so one of the first options you're going to see is you're going to see the trans limit x. Okay? So where it says current, you'll have an arrow to the left and to the right of it. Click on the arrow that is to the left and it'll actually change the minimum value. Then click on the box to activate it. And so now this becomes the minimum value for that joint. And you want to go to each joint and do the same thing. Set the minimum and activate it. Wrist, minimum, and activate. Now, of course, make sure that everything is back at its default before you do that, so that you're actually getting the correct minimums. Okay? Because we don't want it to go below our original defaults. Unless you want that for some reason. So I took my IK handle and just parented it to the control just to make it a little easier to demonstrate. So when I actually grab the control now and I translate, notice how the arm doesn't scale below our minimum values, but it stretches normally and follows our controls and everything is fine. Okay, so this is a much simpler setup in a way, because there's no measuring, it's simply observing the default translate values of our joints, plugging them in to a few utility nodes, and then plugging their output back into the structure. Now, even though the basic setup gives you a fairly decent stretch within the x-axis. It's not going to give you a good stretch in the other directions because it doesn't know to pay attention to those directions. But it's only being told to stretch along the x-axis. So if you pulled up or down, the stretch wouldn't be, actually it probably wouldn't stretch at all, except in response to any accidental pull along the x-axis. So what you need to do is we actually at this point need to add in the distance measuring tool and a couple other nodes so it can actually keep track of the length of the arm no matter which direction it's pulled in, and so that it can actually regulate the scale of that stretch even when the rig itself is being scaled. So first you need to go to the Create menu, Measuring Tools, Distance Tool, and then click at the beginning of your chain, in this case the shoulder, and then at the end where you want the stretch to occur, in this case the wrist, and it will create a locator at the start and at the end of the selected range, and it'll also create the distance dimension node, which will immediately specify the distance. Okay, so now that you have your locators and your distance dimension node, we need to create a couple other nodes so that we can basically take this arm from being a translation responsive stretch to a distance responsive stretch. So simply bring up your window. You can use your node editor or you can use a create node. I'm just going to use the hypershader to rendering editors, hypershade, bring that up. And simply go to utilities and create another multiply divide node and create another plus minus average node, or you can go to your utilities tab, select one of your existing nodes and just duplicate it and rename it, but good idea to start clean. So plus minus average node and a multiply divide node. So now take each one of these and of course rename them just to simplify them, but to also make them clear to the purpose. In this case, the plus minus average node is going to essentially act to zero out the effects of the distance on the joints, because by default we need them to be at their default position, which is already set in their nodes. So we need it to zero that overall distance. So I'm going to call this one my plus minus zero distance. The multiply divide node we need to basically gauge and to affect scale. So I'm going to call it my mdiv, and we'll say global scale. Okay. Okay, so now I have that. And so now for our global scale, let's handle this one first. Just double click on it, brings it up in the attribute editor. We need a couple of things to be fed into that. So if you actually look in your workspace, you have the distance already listed for you. And so in our first box, we need to take the distance and drop it into our input 1. Okay? And so I'm going to just type it in up to the third decimal. 1.738. And then in the Y slot, also under the input 1, we need to put in the number of joints that the stretch is going to be affecting. Because what this global scale node is going to do is it's actually going to use the global scale of the rig to basically regulate the distance and the effects of essentially the joint count on the stretch. And so we have 3 joints, so that goes 3 in there. And now we need to take our global scale node, we need to connect it into our global rig control, which is this little circle around his feet. Basically the one that or whichever attribute you're using to control the scale of your rig. If you don't have one, you should consider making one. If you don't have one, you don't really need to make this node, but if you do plan on having a scalable rig, you need this node. So select your multiply divide global scale node, and you want to select your global curve first, then shift select the multiply divide global node, and then go to general editors, connection editor. Brings up your connection editor, and it should have everything loaded in the right order. Main should be on the output side, and multiplyDivide node with your global is on the right side. And then you want to basically just take any one of the scale attributes. I usually use scale Y, and feed it into not the input 1 but into the input 2, because that's the one that's on the bottom, where everywhere it was listed 1 all the way across, which will correspond with the default scale. And so just feed scale into the input 2x and the input 2y. That way when you actually look at your node, now we have basically that scale feeding in and multiplying times our distance and our joint count. Now, before we move on, in the case of the distance, we're actually going to use this value to negate the effects of essentially the distance that's being measured for the arm, which is a positive value. So we need to negate it, so we need to make this negative. And so we're going to make this negative by basically just typing in a minus before the value, and it makes it negative. Okay? And so now we're going to need to take these values, we're going to feed those in, this value at least, and feed it into our next node. So I'm going to reload the left side since I have my global scale node selected, and so now the global scale node's in your outputs. And now we need that plus minus 0 distance node that we created. And I'm going to use, let's say, in this case we'll use the input 3D, and I'll just hit add new items there twice, so we actually have input 3D 0 and input 3D 1 with both with an X, Y, and a Z. We're just going to use the X, but I usually like to have the extra slots. You never know when you're going to need them. Okay, and so I'm going to load that node up in the right side, just reload, and I'm going to make sure that I can see my outputs for the global scale. So I'm going to go to left display and tell it to show non-keyable, and then expand my outputs. And so now in the case of the plus minus 0 node, we need to do a couple things. So first of all, we're going to need to put in our default value, our default distance, and we're going to need to put in a distance to negate it. So we're going to get the distance, first of all, we're going to get that from our distance node. So we'll put that in a second. So right now I'm just going to put in our connection to our negated distance, which is on the output X of our global scale. So I'm going to select that, and I'm going to expand the input 3D, I'm going to expand the input 3D 0, and I'm going to connect the output X to the input 3D 0, input 3D X. Okay? So now that I've made that connection, I need my distance dimension node. So I'm going to zoom out, I'm going to just click right on that distance dimension object. I'm going to press the down arrow on my keyboard so I can actually select the shape that's related to that top level object. Or you can even come over to your attribute editor and just click on the tab and then hit the select button to select it. And then what you want to do is you actually want to reload the left side so that you can actually get that distance dimension shape loaded up, and then go all the way to the bottom and you should see distance, select distance, and then you want to expand the input 3D1 of your 0 distance node, and want to feed that distance into the input 3D1 of the input 3DX. Once that's done, if you take a look at your node, you can actually see now we have 1.7 being added to a negative 1.7, which equals 0, and that's exactly what we want for now. So we have both of our brand new nodes set up, and now they need to be connected to actually feed in and actually affect the structure. And so to do that, we only need to feed them actually into one node. Instead of having to feed them into every single node that was already connected, we just need to feed them into the node that controls stretching right now. And that node is our mdiv stretch node. Okay, so you want to load that in there. And if you actually take a look at your mdiv stretch node, you'll see it already has a few incoming connections. And that's from what we've already done in the previous setup, just so that it responds just to translate. Okay, but in this case, we're going to need to make a few changes. So load your MDiv stretch node up in your connection editor, Window, General Editors, Connection Editor. But you want to load it on the input side, so reload it to the right side, and then we can actually take our nodes and start making connections. So first, let's actually handle the distance. So the distance is going to need to feed into our input 1 for our MDiv stretch. Now currently it's receiving a connection input from the curve that we're just translating, and it's receiving its translation value. We need to actually change it so it's not actually receiving the distance, or shall I say the modified distance value, from the plus minus 0 node. Okay, so we select that node, reload it on the left side, and then we get its output 3dx, which is our negated value, and we feed that into our input 1x on the multiply divide stretch. And now if you actually click on the multiply divide stretch, you can actually see it's still 0 because it's pulling in that negated value. Next, we need to actually take our multiply divide global scale, and we need to load its modified joint count value that's being multiplied times the scale. Now that needs to feed in to the input 2x on the multiply divide stretch. So select your multiply divide global scale node, reload the left side, expand its output, and then remember that that converted joint count is actually being fed in from the output y of our global scale. And so now take that value, the output y, and feed it into the input 2x of your multiply divide stretch. Okay? And so once that's done, you're pretty much ready to go. So if you actually grabbed your locator that's nearest the wrist and you pulled it, you should actually have a perfect stretch happening. Okay? Now the next thing you need to do is do a little cleanup. So I'm going to close some windows. And so what you want to do is you want to take your locator for the shoulder, or basically the locator at the start of your stretch position, whether you're doing this for a shoulder or a hip or whatever. Take the start, select that select the joint that it corresponds to, shift select that locator, and then point constrain it. Don't parent it, because parenting will cause it to inherit, and that will cause problems. What we want to do is we want to constrain it just so it's anchored there. So joint first, shift select the locator, constrain, point constrain, and once it's constrained, you can select that locator, go to the channels box, set its visibility to 0. And then you can set the distance to 0, and then the locator nearest the wrist. Once again, you can do the same thing. You can point constrain this one, or you can actually parent it directly to whatever control you're going to use to control the stretch. You could, if you're going to use the IK control to do so, that's fine. If you actually want to maintain a separate curve control, that's fine. But something that's going to have it follow and stay aligned with the wrist and hopefully your IK handle. But of course, once it's anchored, simply set its visibility to 0 so that you just have your control and pretty much the joints. Then you can go through and create your IK handle if you're going to use IKs, which you should, because it will keep everything aiming in the right direction and stretching. And so you can take your IK handle and you can anchor that to your whatever control you're using. And then when you translate, you'll get a perfect stretch that works in every direction. And because of the limits that were put on the joints, of course, everything still works normally there too. Okay, so if you did everything right, you should be able to take your control, parent it to your global or into your global hierarchy, basically, and then you should be able to scale with no problem. Now, I have a few other limbs here that also have stretchy on them that either are not connected to the scale and the global, so you can see what happens, or they're connected, not part of the hierarchy and not connected, just so you can see what kind of things occur when some connections aren't made properly. And then we have our arm, which is connected properly. So I'm going to scale up first. And so if we see as it can scale up, the leg is stretching oddly because it's not paying attention to the scale properly. And the same for the arm here. And again, it's also not part of the hierarchy, so it's getting left behind and the arm's just doing weird things. But then we have the arm that we just finished setting up, and it is scaling perfectly with the rig. No problem, performed normally. And even if we put it into a pose like this, and then I scale down, it will still be perfect, while everything else is a little odd. Okay? So even at 30% of its original size, it still performs admirably. No problems, no lagging, nothing, no problems with no conditions to worry about. Everything just works real time, no problem. And if I type in 0 and put it back to its default position, it goes specifically back relative to the scale. Okay? So that's pretty much what you want. If yours is doing something different, something like what was happening with my leg here or with the right arm, then you want to worry. Now, one thing to keep in mind when you are setting up the right arm, that once you actually put the plus minus average nodes on that side, is that the values are usually going to be negative. So you're probably going to have to subtract those within the plus minus operations for each one of those nodes.